Okay, we're now going for number 2b, which is the second type of question. Okay, the second type of question, are we going to get it? Definitely we're going to get it. It's obvious. It's not even hard. Here's what they want you to do. Here's what they say. They say express this, whatever you're going to get, make sure it is in the form dy dx plus py is equal to q. Okay, are you seeing this? Make sure it is in this form. Dy dx plus py is equal to q. Simply what it means is make dy dx the subject, not the subject, but make dy dx be alone, and the thing with y will go to the same side as where dy dx is. Okay, make sure if dy dx is a number, then divide everything by that number to get him away. Get him away. We want dy dx to be alone. Now if you look at the situation which they gave us, dy dx is already alone, so we say yay. So now what we are going to do is, because once you express it in this form, you can be able to see what we need to do when we are doing this. Because what you're going to do here is what the integral factor is. We are going to have this. It's going to be y e to the integral of p with respect to x is going to be equal to the integral of e to the integral of p dx times q. Have you seen this? Where is it hard? In u, it was actually y is equal to this q, right? But we're going to bring this whole idea. Watch closely. Y e to the integral of p dx is equal to the integral. So the right hand side, you are going to integrate what? E to the integral of p with respect to x. So we are first going to find the integral factor. The integral factor is something which helps you to then integrate. We want to integrate. And the integral factor is something which helps us to integrate this e to the p with respect to x. So to the integral of p with it. So we are actually going to get e to the integral of p with respect to x. I know everybody's like, what are you saying? We are going to get this class we're going to get e to the integral of p. What we are going to do, we integrate p with respect to x. Where do we get our p? We are going to get him after we express our equation in this form. We are going to get our p, and then when we get our p, we are going to get the integral of p with respect to x. When I have the integral, so you get p. Remember, put it in this form, then get p and get q. Q will be whatever is going to be alone, and p is going to be. We are going to need them both. Now the p, you're going to integrate it. Then when you integrate it, you express it in this form. After integrating it, you're going to express it in this form. Then you take that form and you put it in this equation here. This equation here now. You understand? Don't want to hear anyone saying they're not able to do it. Let's do it right now. Let's do it right. I don't want to hear anyone saying they're not able to do it. So what you're going to do, number 2b, don't be writing formulas. Don't you write me formulas. Don't cram formulas because they can leave you. But first, what you're going to do, make sure dy dx is the subject. So yes, you have here dy dx is equal to 3 over xy, which is going to be equal to cos x over x cubed. So here they said use the integral factor. The moment you see them say use the integral factor, you check, is dy dx the subject? Is it not the subject rather, but is it alone? It should have this guy with, this is a plus. They should be together because this guy is the one with y. So number one, dy dx should have no number in front of him, nothing, and the thing with y should be right next to him. Then the thing with just x should be on the other side. Is it what is going on? Yes, well done. If that is what is going on, we say to you, my friend, you have expressed it in the form dy dx. This is the form, right? Dy dx plus py is equal to q. You have expressed that this is the form you want. Dy dx plus py is equal to q. So now you're going to come here below and say, let p be equal to 3 over x, because p is the number before y. Is whatever is before y. It is 3 over x, right? Then you're going to say q is going to be equal to this thing, the other thing, cos x divided by x cubed. We're going to use them both. Cos x divided by x cubed. Okay, so what are you now going to do? You're going to find the integral of p with respect to x. This is going to be the integral of what is p? 3 over x with respect to x, isn't it? Now here we have just an x in the denominator. Remember that other situation, we didn't have just a y. That's when we made the top be the derivative. But when you have just an x, what you're going to do is you bring 3 outside. 3 comes out. We have the integral of 1 over x with respect to x, because it was just an x. And we're going to have 3. The integral of 1 over x is ln x. Okay, so here we have 3 ln x. Don't say plus constant of integration c for this one, because we are not yet done. We are not doing that here. So we have found our integral of p with respect to x. We have you found it? Yes. Now what you're going to have, what are you going to have? So integral factor, remember your integral factor is now going to be what? Is e to this answer. It is e to the integral of p with respect to x. We have found the integral of p with respect to x. So we are now going to raise it to the power of, we're going to put it as a power of e. So it's going to be e to the 3 ln x. We now have e to the 3 ln x. In other words, we now have e to the p with the e to the integral of p with respect to x, because the integral of p with respect to x will be something. It won't be an integral, it will be something. We got it as 3 ln x, so we put it there. Now what we are going to do, we are then going to write this form. We are now going towards the solution. We now go towards we have expressed the first equation in this form. We found the integral of p with respect to x. We change it to be the integral factor. Now we put it into this one. So we now say y times the integral factor. You multiply the integral factor at y and then on the other side. So it's going to be y is going to multiply the integral factor, which is e to the integral of p with respect to x. This is going to be equal to the integral, please. It is equal to the integral of e to the integral of p with respect to x times q. So we are now going to say y multiplying, what is this? E to the 3 ln x. This is going to be equal to the integral of e to the 3 ln x times q. And what is q? Q is cos x over x cubed. Okay, and we're going to be, it is going to multiply q, which is cos x over x cubed, and we integrate this whole thing with respect to x. We're integrating it with respect to x. You understand? Then what are we going to have now? We're going to say y. Okay, this is now, can you see? This is where you plug it in. All the work you're doing is to plug it in here. This is the most important equation. I don't know how to tell you. Make sure you're hearing me. This is the most important equation. Write it down 900 times. Make sure you're not forgetting it, because this integral factor, you can find it, but what do you do with it? You put it in here, then you integrate. You understand? Now we integrate. So here it's still going to be y e to the 3 ln x is going to be equal to, we are now integrating this thing, right? We're integrating this thing. Now, I mean, let's simplify, before we go ahead, let's simplify. We do know that when you say e to the ln, they cancel out because they're opposites. When you say e to the ln, they should cancel out because they're opposites. So we can say that here we can simplify this, right? It'll be y is equal to e to the ln x cubed. First we take this thing back to be the power, right? Which is now going to be here, we have it's the integral of, again, e to the ln of x cubed, because you can take it back, right? Times cos x over x cubed with respect to x. You see how easy the situation they would given you. So we're going to have y. We have here y is e and ln cancel out, and this thing just comes back as it is. So it's going to be y times x cubed is going to be equal to, again here, the integral of x cubed times cos x over x cubed dx. Okay, then what will actually happen here is you're going to have this x cubed and this x cubed cancel, right? Then you're going to have y x cubed is equal to the integral of cos x with respect to x. Now when we integrate cos x, you need to be having your table. You need to be knowing the table of derivatives. I'm just gonna give it to you so that you have it somewhere in here in case you wanna use it. But here you'll be like asking yourself, so here's basically, let's do for the trig ones. Okay, just for this, we'll be saying we have y, then we have y prime. Sine x differentiates to gives you cos x. Cos x differentiates to give you negative sine x. So when we're integrating, we're going vice versa. You look for cos x, it is here. When you go vice versa, it gives you positive sine. Okay, positive cos gives you positive sine. So we have y x cubed is equal to sine x plus c. Now you put your constant of integration c, and now you have to find it. Once you find it, you're done. This is so simple, right? So we're going to say, okay, we're going to say maybe let x be equal to, they said pi over 2, y is 0. Let's x be equal to pi over 2, then y equal to 0. So you're going to have 0 by pi over 2 cubed is equal to sine pi over 2 plus c. This is going to be 0 is equal to, we now punch sine pi over 2. Make sure your calculator is in red. Make sure your calculator is in red because you're punching sine of pi over 2, which is like to say sine 90. You must get 1 plus c. Then you take 1 to the other side. Negative 1 is equal to c. So we're going to get c be negative 1. Now we just then write it. We're going to now say yx cubed is equal to sine x minus 1. You see? Then what are we going to now do? We make y the subject if you want. Y is going to be equal to sine x over x cubed minus 1 over x cubed. And you are done. Oh my goodness. How many marks was this? 20. For free? Really? Winner? Make sure you get this free 20 marks.